Hey guys, this is a video to help compare ratios using unit rates. I am going to do a couple problems for you here. In these first two problems that we're going to look at, we are going to determine which is the better value. And when we're talking about a better value, we're looking for which one is more inexpensive, which one's cheaper. Okay, so the first thing we're going to do, as always, is draw ourselves some ratio tables. Okay. And we're going to look at the two items that we're comparing. It says 3 kilograms of charcoal for $7.95 or 5 kilograms of charcoal for $12.50. So we're doing kilograms to dollars for both of these. Okay, and we'll put our original ratio for each one of those. So 3 for $7.95 and 5 for $12.50. Okay. Now what we're going to do is we're going to try and find out how much 1 kilogram cost and then compare them. Because right now we can't really compare them because they have different amounts. So once they have the same amount, we can compare the price. So I want to find out per kilogram. So per kilogram means 1. What am I going to do here to get from 3 to 1 and to get from 5 to 1? Here we'll divide by 5, and here we'll divide by 3. Remember, what I do to one part, I'm going to do to the other. What I do to one part, do to the other. So essentially, we are doing two division problems. We're going to do $7.95 divided by 3. And then we're going to be doing $12.50 divided by 5. Now, when I write a division problem that has a decimal, I like to pop it right up into the quotient so I don't forget about it. Okay? Now we're going to start with this one. 3 goes into 7 2 times. Not evenly, so we'll see what's left. Bring down our next place value. 3 goes into 19 6 times, so then we have 18. 1 left over. Next place value. And that goes in 5 times. And finally, we've reached the end. So this one is going to end up being $2.65 per kilogram. Now we're going to look over this next one. 5 goes into 12 2 times with some left over. 5 goes into 25 5 times. Nice and even, but we're not done because we have one more number to bring down here. Okay, so 5 goes into 0 times. Now we're done. Okay, so now that we've filled in our ratio tables, we can decide which one is a better deal. Well, this one for 1 kilogram, it's $2.65, and for this one, 1 kilogram is $2.50. So here, this one will be our better deal. Okay. We do the same thing for number 11. Set up your ratio table. You are going to find out per one envelope how much it costs. And once you have that one envelope, then you can decide which is a cheaper value, a better value. Okay, I'm going to go ahead and erase these real quick. And then we'll move on to, ooh, didn't mean to take away everything. Holy moly. Okay, let's see here. Oop, wrong one. Guys, having some technical difficulties here. Just give me 1 second. There we go. That's what we're looking to do. Okay. So now we're going to go on to some other problems here. And this one, it says, compare the rates to find which one is greater. Okay, so I'm actually going to do number 13 over here. Okay, so number 13. It says 12 laps in 8 minutes or 16 laps in 10 minutes. So I'll do laps to minutes. Okay, and then we'll go ahead and fill in our table. So we have 12 to 8 and 16 to 10. Okay, we want to find out per minute how many laps they can do. Okay, per minute how many laps they can do. So I know I'm going to be doing divided by 8 here, divided by 10 here. Okay, what I do to one part, I'm going to do to the other. Okay, so I'm doing 12 divided by 8. Okay, and then we're going to do 16 divided by 10. Okay, let's start here. That goes in 1 time. With 4 remaining, bring down our 0. 8 goes into 40 evenly 5 times. And so we're done here. This is 1.5 laps in 1 minute. And then we'll go over here. 10 goes into 16 one time with 6 remaining. Bring down our 0. That goes in 6 times. Nice and even. So this one becomes 1.6. So in looking at the two, in 1 minute, this person can do 1.5 laps. But in this person over here in 1 minute can do 1.6, which is a little more. So we're looking, remember, to find which one is greater. So in this one, I would say this one's the winner. Okay, so using the unit rate helps us to compare because we have an equal thing to compare to. In the beginning, 8 and 10 are not equal, so it's kind of hard for us to determine which one is greater or which one has a different, like a higher rate. But when we give it like, when we put it as a unit rate, it becomes an even playing field. So we can kind of look and say, okay, they're about the same, so I can look to see which one is different. Okay, hopefully that makes sense. Okay, I'm going to stop there for today. We'll do one. We did one of each problem, so we found one that has a better value or the one where we're looking for the lesser value. And we did one where we were looking for a greater value. Okay, if you have any questions, please reach out to me and I'd be happy to help.